Hello my test tubes and welcome to another step preparation video. Today I'm going to be going over 2019 step 1 question 1. Before I start, I'd like to say that I do aim to make this channel as useful as possible to people applying for STEM subjects at university, and therefore I would like you guys to interact with me and write to me in the comments what sort of thing you'd like me to go over next. And this can range from Olympiads in a certain subject, some STEM subjects such as astronomy, physics, maths, engineering, anything, to specific entrance exams such as the MAT and the PAT and the TMUA, though I'm not sure I can help you with the TMUA. But basically, tell me and I will provide. Okay, so for the first part, we're told that we basically have a point at 1k and a line going through it with gradient minus tan theta, so there's going to be an angle theta here. I'm going to convert this sort of description of the line into an equation of the line using the usual algorithm of we have a point 1, do stuff with it. So y minus k is equal to minus tan theta times x minus 1. At y equals 0, we have minus k is equal to minus tan theta x minus 1. So k cot theta plus 1 equals x, that big x. And then for x equals 0, we have y minus k equals minus tan theta times 0 minus 1. So y equals tan theta plus k, yes. Then find the area of the triangle OXY. That's just going to be the height times the base over 2. So that's half times tan theta plus k, that's the y coordinate, times k cot theta plus 1. Expanding gives half times k squared cot theta plus k plus tan theta, giving me a half k squared cot theta plus 2k plus tan theta. Now here, when they ask you to give them minimum, you can often be confused. You can often be confused, as I was, with trying to find the minimum of the quadratic, and that gives you one of the solutions, but it gives you the wrong solution. What you're actually supposed to do is find the minimum with respect to theta, because k is already fixed, and for this you have to differentiate the value of a. So dA by d theta is equal to a half times k squared times minus cosec squared theta plus sec squared theta. And d over d theta is therefore equal to 0 at k squared cosec squared theta is equal to sec squared theta. So k cosec theta is equal to plus or minus sec theta. And the minus sec theta doesn't work because we'll have k cosec theta is positive because sec theta is acute and larger than 0 and k is positive, and sec theta is also positive. So you have minus sec theta, you have positive thing that equals a negative thing, and that's bad. So that means that we have k cosec theta is equal to sec theta instead, and so k is equal to tan theta. Plugging this back into the equation, we get a half times tan squared theta times cot theta, which is 1 over tan theta, so tan theta plus 2 tan theta plus tan theta, and that's just 1/2 times 4 tan theta, so that's equal to 2 tan theta. Great. Part 2. L is going to be the length OX plus length OY plus the length XY. And to find that, we have the length OX, which is equal to k cot theta plus 1 plus OY, so tan theta plus K, and then plus square root of K cot theta plus 1 plus tan theta plus K, because these are squared, because Pythagoras. And here I got disconcerted because I had a square root, and I'm not great with square roots of trig functions, apart from the obvious ones. So I decided to look at the results, and we have 1 plus tan theta, 1 plus tan theta, where there's no factors of k, but we need a sec theta where there's no factors of k, so this has to give me a sec theta, and then we have a k cot theta plus k, and so we're missing a k cosec theta, and that's all we're missing, because all the other things are provided here. So what I need to prove is that the root of all of this is equal to this, or as well, same thing, that sec theta plus k cosec theta squared is equal to the thing under the root. Sec theta plus k cosec theta squared is going to be sec squared theta plus k squared cosec squared theta plus 2 sec theta cosec theta, and the thing under the square root is going to be k squared cot squared theta plus k cot plus 2k cot theta plus 1 plus tan squared theta plus 2 tan theta k plus 1. Oh yeah, sorry, there's a k over here, which is equal to k squared cot squared theta plus plus k squared, and that's k squared cosec squared theta plus tan squared theta plus 1, and that's plus sec squared theta, then plus 2k times cot theta plus tan theta. But looking at cot theta plus tan theta, that's just cos over sine plus sine over cos, which is cos squared plus sine squared over sine cos, and so that's equal to sec theta cosec theta, which is exactly what we have over here. So the two things are equal, and so we've proved what is required to prove. Next, we're asked to find a minimum, given that a minimum exists, and just as we did with A before, I'm going to find dl by d theta, and that's going to be equal to sec squared theta plus sec theta tan theta plus k times 0, cot theta differentiates to minus cosec squared theta, and then cosec theta differentiates to minus cosec theta cot theta. So I'm just going to change it to the minus and give this cosec squared theta plus cosec theta cot theta. Yeah, and that's 0 when sec squared theta plus sec theta tan theta is equal to k cosec squared theta plus cosec theta cot theta. So 1 plus sine theta over cos squared theta is equal to k times 1 plus cos theta over sine squared theta, and so k is equal to 1 plus sine theta times sine squared theta over 1 plus cos theta over cos squared theta. And here, I think continuing on from this is not extremely intuitive. You just have to play around and get it. If you don't get it, then I guess you're unlucky, which is not the type of question I like in STEP. I like in STEP where if you're good at maths without spotting stuff, then you should be fine. Or at least you should be good at spotting stuff, but also that spotting stuff shouldn't rely on some random thing you thought of. It should rely on you being good at spotting stuff, not chance. Anyways, so what you have to spot here is 1 plus sine theta times 1 minus cos squared theta over 1 plus cos theta over 1 minus sine squared theta. And here you expand 1 minus cos squared theta as 1 plus cos theta, 1 minus cos theta, and you have the 1 plus cos thetas cancels, and the 1 plus sine theta also cancel, giving us 1 minus cos theta plus 1 over 1 minus sine theta is 0. Gives us the value for theta when it is a minimum or maximum, and because for small theta, for acute theta, there's only one, that's going to be v, and this gives us a value for theta when it's a minimum or a maximum, and so alpha has to obey this, and so 1 minus cos alpha over 1 minus sine alpha is equal to k. Alpha has to obey this if it's going to be the minimum. Find and simplify the expression for the minimum value of L in terms of alpha. Well, that's going to be 1 plus tan alpha plus sec alpha plus k, which is in terms of alpha, times 1 plus cot alpha plus cosec alpha. But here I went down a huge rabbit hole of trying to simplify lots of stuff that I didn't really want to simplify, and so I got back to here and tried again by simplifying this whole value before I introduce k. And to do that, I'm just going to say that this is something all divided by cos, so that's going to be cos theta plus sine theta plus 1 over cos theta plus k times sine theta plus cos theta plus 1, all divided by sine theta. This gives me cos theta plus sine theta plus 1 times 1 over cos theta, and here I'm going to introduce k, plus 1 minus cos theta over 1 minus sine theta times 1 over sine theta. Expanding the denominator things here, I get cos theta plus sine theta plus 1 times 1 minus sine theta times sine theta plus 1 minus cos theta times cos theta, all over sine theta cos theta times 1 minus sine theta. Simplifying this stuff is going to give us, I'm just going to move this up. Simplifying this stuff is going to give cos theta plus sine theta plus 1. Sine theta plus cos theta, and then we have minus sine squared theta minus cos squared theta, so minus 1. So cos theta plus sine theta minus 1, all over sine theta cos theta 1 minus sine theta. This is using the difference of two squares formula, cos theta plus sine theta squared minus 1 over sine theta cos theta 1 minus sine theta, and that's going to be cos squared theta plus sine squared theta, so 1, plus 2 cos theta sine theta minus 1, so just 2 cos theta sine theta over cos theta sine theta 1 minus sine theta. Cancelling these gives me 2 over 1 minus sine theta. Yay! I hope you guys enjoyed this, and I hope also that your exams go perfectly well.